we're going to look at probability and specifically conditional probability. Under conditional probability, there are 5 key things that you need to know. Number 1, conditional probability is given by A given B. It's a condition of one event occurring given the other occurrence. So they are what we call formulas, which are axioms of probability. They're about 13 to 15, but for this particular case, we're going to dominate on only 5 or 6. The first one here is the union. The union set means to add. So A union B means you're adding what A and B has. So when you hear the word or, it means you're uniting. A or B means we're doing what? We're uniting. So we're adding. So what it means is probability of A plus probability of B minus the intersection of A and B. But what is the intersection? The intersection is a common ground, what A and B has. So this middle part here is called intersection. The word that we use to understand intersection is the word and. And means multiply. So what is common between these two? So if we're going to find the formula for A union B, it's a probability of A plus the probability of B minus A intersection B. So A, what A has and what B has, we subtract what is common. We go to the probability of A intersection B. So we're going to have this one come the other side. The union will go the other side. It's simply the same formula we're making subject of the formula. Now, key is this formula which we call Bayes theorem. Bayes theorem. So Bayes theorem as it's a pattern. So if you're given the probability of A given B, so what you need to emphasize, the B goes down there, will intersect A intersection B. If you have B given A, the A will come down there, we're going to intersect B intersection A. Is that clear? Okay, so it therefore follows that these intersection sets that you can see there, they will spring out from this formula. So we can say A intersection B will simply be, when we cross multiply this times that one, we're going to have probability of A given B times B. And when we go to the other one, B given A to get the intersection, by the way, A intersection B is the same as B intersection A. So the intersection here is the most inconsistent formula because you need to know when to use what formula given the data. So you need to be careful. So if you're given B given A, let's multiply it with the base here. B given A times A will give you what? Conditional probability here. So with that being said, we now go to our calculations. Other axioms that we have using the same format, if you have A given B complement. So a complement is what you don't have. So if A is 20%, the complement is 80%. So A complement is simply 1 minus A itself. So if A is 10%, the complement should be 90%. So A and its complement must give you 1. Similarly, B plus its complement must give us 1. So if I've given A given B complement, the B complement will go down there, then we're going to have A intersection B complement. So we know that B is 1 minus B itself. If we have A complement given B, the B will come down there, then we're going to have A complement intersection B. So there's what we call theorem 2. Theorem 2 is such that the probability of A is simply A intersection B plus A intersection B. If A is subject, the complement will be on the other letter B. If B is subject, the complement will be on the other letter A. But the idea is you need to see the letter which is common. We have A which is common because B and B complement are not the same. Here we have the letter which is common is what? B. That's why it's subject to formula. Here we have A intersection D plus A intersection D. The total will give us a probability of what? Of D. So with that being said, I'm going to look at the assignment question. Consider an an insurer that offers two types of policies. We have what is called the home and the car. So we can let home be what? H, and let car be what? C. So the home insurance, we're told, is 87% of all customers have home insurance, so 0.87. And we're also told that 96% have what? Car insurance, so 0.96. Then every customer has at least one of the two. So when we add these two, at least the total must be 100, meaning each one should have at least one. So A union what? H, C union H is equal to 1. So the first question is asking, if a customer is randomly selected, what is the probability that they don't have a car insurance policy? So part A is asking for us to find what? The complement of car. So C complement. What is the complement of C? It's 1 minus ability of C. So if C is 96, 0.96, and subtract it, the remainder is 4%. So here we're going to have 0.04. But B has a car insurance and means what? Intersection. So has a car insurance, intersection what? Home. So using the second formula here, we said since we have the intersection in the formula, this one can come and this one can go the other side, depending on what information has been given. So this means that we're going to have probability of what? C plus probability of what? H minus the intersection of C intersection H. What's the probability of C? We're given as 0.96. What's the probability of H? 0.87. And the union of C and H is what? 1. So quickly, what do we get? When we add 0.96 plus 0.87 minus 1, what do we get? 0.96 plus 0.87 minus 1. What are we getting?
0.83.
0.83. Okay. Exactly 0.83. So get 0.83. So we are done with part B. Part C, what is the probability that it has a home insurance given that he has a car insurance? So probability home insurance given that he has what? Car insurance. So in this case, we're going to have our car insurance down here. C goes down there. Then we're going to intersect H intersection what? C. The probability that he has a home insurance given that he has a car insurance. So we say home intersection C is the same as C intersection H. Much as it is the same as 2 times 3 is the same as 2. So the intersection we just found as 0.83. And the probability of C is 0.96. What are we getting? Divide 0.83 divided by 0.96. 0.83 divided by 0.96. What are we getting?
0.86.
Divided by
0.86.
0.83 divided by 0.96. What are you getting? Opening my calculator. 0.83 divided by 0.96. we're getting 0.8646. Please don't round off. 8646. So 0.8 together. Go to the last part of the question. We're being asked to calculate probability that does not have car insurance, given that he has a home insurance.
Correct.
So the narration is does not have the car insurance, so C complement, given that he has what? A home insurance. So to explain, we're going to have what? Probability of C complement intersection H over the probability of what? H. Now, this is theorem 2. So whenever we have a complement on C, the shortcut is simply H minus the intersection of this. H minus the complement of C intersection H. The complement was on H, would have put C minus the intersection of C and H. That is how theorem 2 works. So our probability of H was 0. What? What was the probability of H? 0.87. Intersection just found as 0.83. So H was 0.87, intersection 0.83 over probability of H, which is 0.87. So what are you getting? 0.87 minus 0.83 will be 0.04. Divided by 0.87, what are you getting? 0.04 divided by 0.8.
0.0459.
We get 0.0459.
59.
Like this. So that is how we're supposed to answer the first question. Any questions at this point? I've already sent you the recordings on how in depth to go about that. Okay, so now let's go to the second question. Let's put that in a study to compare two different methods of teaching in a class. We have 30 children who are divided into two random groups. Each group is taught using one method. After 6 months, the two groups were given the same test, one pupil. In the first group was ill and missed the test. The scores are given as follows. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here they're all 15, but in this group they're 14 because one was ill. So we're being asked to calculate the extreme values of each group and the quartiles. And we're asked to draw what is called a box whisker box for each of the groups. Now, here's what we call a stem and leaf diagram. Stem and leaf diagram will help you identify the extreme values. So we come up with the smallest number here for method 1. The smallest number here is what? 50. Then we have no 60s, we go to 70s, we go to 7, 80s, we go to 8. If the 90s, we would have put a 9. So we're just getting the first numbers of each of these figures there. We're just rearranging them. So now we want to arrange them in order. So for method 1, what's the smallest number? 50. So we'll put 50, which is that one here. There are no 50s anymore. Then when we go to 60s, there are no 60s. We now go to 70s. The smallest number is 71. So there's already a 7 there. We'll put 1. So 71. And the next number is 72, which is this one here. 73, which is this one here. 76, which is this one here. And 79. So we're done with the 70s. We go to the 80s. We have 80, 80, 81, 85, another 85, another 85. Okay. So 85. So just following that. Then 87, this one, and 89. So we'll make sure that they're 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So far, are we together? So far, we're together?
Yes.
All right. So now, let me deviate briefly. The stem leaf diagram is a very important parameter that helps you summarize data that is what? That is a summary that you get. So from the stem leaf diagram, we are able to identify a lot of parameters, starting from the range, to the median, the quartiles. So let me extract this briefly here. So here, let's identify what we call the range. Our range is the smallest number. So x mean minus what? X max. So here the highest number is what? This is not 9, but 89. And the smallest number is what? 50. So this is what we call the range. Okay. Then we go to the mode, the number that appears the most. So we have 5, 5, 5, 5, 5. So this number is not 5, but what? 85. Then we go to the quartiles. So what we call the lower quartile. The lower quartile is a quarter of n plus 1. So these are 14, a quarter of 14 plus 1. What is 14 plus 1? 15. What is a quarter of 15? What is a quarter of 15? 3.75. Is it? The nearest number, we're going to get the fourth number. So you count number 1, number 2, number 3, number 4. So this is called our lower quartile, or first quartile. What number is that? That number is 73. So our Q1 is 73. So we have 3 quartiles. We have what we call the lower quartile. We have what we call the second quartile, which is also the median. This is half of n plus 1. So 14 plus 1 is 15. Half of 15 is 7.5. Whenever you get a 0.5, you get that number and the following number, you divide by 2. So this means the 7th number plus the 8th number, you divide by 2. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. So these two numbers, 81 and 80. 80 plus 81 divided by 2, which will give you 80.5. So the quartiles give you the position and not the answer, but you need to identify the answers in that regard. At this point, before I proceed, any questions? Are we together? Agatha, Sula, are we together?
Yes, we are.
All right. Then when we go to the third quartile, this is 3/4 of n plus 1. So in these figures, I've mentioned to say when you get 2.25, the nearest number is what? 2. To get 2.75, the nearest number is what? 3. But if you get 2.5, you get the second number and the third number, you divide by 2. That is how it goes. So 3/4 of 14. But we get 3/4 of 14 plus 1, which is 15. But we get
11.25.
the nearest. So which position are we getting?
11.
11. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What number is this?
85.
Excellent. So that is 85. So our Q3 is 85. And the difference between the highest number of the quartiles and the lowest number of the quartiles is called the interquartile range. So the third quartile minus the first quartile. What was our third quartile? 85. And the first quartile, which was Q1, was 73. So the difference between 85 and 73, we get 12. This is called the interquartile range. This is called the interquartile range. Sula, Q3 is called what? The third or the upper quartile.
The upper quarter
And the Q1 is called what?
or the lower quarter.
Or the first quartile. The difference between the two
Yes.
is called what?
The medium, then the middle.
The interquartile range. Okay.
The quarter, yeah, the quarter range.
Yes. Then half of the interquartile range is called the semi-quartile deviation. Half of the quartile called the semi-quartile deviation. Semi-quartile deviation. So half of the interquartile range is half of 12, which is what? 6. Okay. So after finding this, we need to learn how to draw what is called the box whisker diagram. The box whisker diagram has 5 summary points. What are they? I know I explained this to the part-timers. Please don't embarrass me in the distance, guys. There are 5 key points. Number 1. The box whisker diagram, we need 5 key points. Number 1. The x mean, the smallest number. Number 2.
The highest number.
Highest number, x max. Number 3.
The quarter one.
Quarter 1, good. Number 4.
Quarter 2.
And number 5. And number 3. Good. Who is that?
Yes, quarter 3. Solar.
Yes, so that at least I'm very happy. You're representing the customers. Yeah. So the minimum value we had in this was what? 50, and the maximum was what? 89. So here we have 50, 89. The first quarter was what? First quarter was
73.
73, then we went to 80.5 and 85. 73, 80.5, and what? 85. So how do we draw the box whisker diagram? Can use a number line. Okay. So maybe here we have what? 50, 55, 60, 65, 70, 75, 80, 85. 50, 55, 60, 65, 70, 80, 85. So the lowest number here is 50. The highest number is 85. So the box starts from the Q1. 73 is somewhere where here. Our Q3 is 85. The highest number was 89. So 89, 90. 89 is somewhere here. The box will be here. Okay. So this is our Q1, which is what? 73. Our Q2 is somewhere here, 80.5, and our Q3 is 85 here. So our interquartile range is a very important attribute. Interquartile range is given by 12. So our IQR is 12. So we need to find what is called the correction term, the adjuster. We multiply 1.5 times the interquartile range. So 1.5 times 12, what we get? 1.5 times 12, what we get?
18.
So you go to these lower quartile and the upper quartile. To the lower quartile, you subtract minus 18. To the upper quartile, you add plus 18. Any numbers from the values we had here that will fall outside this range are called outliers. So here we subtract our Q1. What is 70 minus 18? What are we getting? 70 minus 18, what are we getting?
52.
52, so it's somewhere here. Then 85 plus 18, what are you getting?
33.
85 plus 18.
103.
So this 90 is protected because it's inside the survive. But this 50 is outside the 52. It will be called an outlier. So this is what we've just done. The interquartile range was 2. The correction term. So 1.5 times 12, we subtract from the lower value. The lower value was what?
Was 50.
Not the lower value. It's supposed to subtract from the lower, the lower quartile here. So 73 minus 18. What did you get?
55.
55. But who gave you 52? I just didn't hear you properly. So it is what? 55. So 55 is here. Still the 50 is outside, so 55 is here. So this is where the 55 is coming from. So meaning when we add the correction term 085, we got 103. So if you plot it here, you discover that for method 1, the 50 is an outlier. Okay, so it's ending at 55 here. Then here, the 90 is protected because we're ending at 10103. So this is how you draw, and when you're commenting, you can comment as follows. In the plot for group 1, it's longer than the plot for group 2. So we have group 1 and group 2. You can see that group 1 is longer than group 2, which shows that the overall variability is more in group 1 than in group 2. Variability is the ability to hover, to deviate from this mean. So this one is longer. The variability is longer for group 1 than group 2. Group 2, these whiskers here are close to the box. And also the interquartile range for groups, you can also comment in terms of that. Okay. And also other things besides that. So I'm just trying to preempt what you're supposed to do in your assignment. You do the same for group 2 and find the interquartile range, you find the quartiles, and also do the box whisker diagram. Is that clear? Okay. So I'll end here.